All right, still on page 297. Now I'm just on the bottom part of 297. Let's go over some more examples. Okay, determine whether they're equivalent. So same thing we were doing. All right, so here we have this expression, and we're comparing it to this expression. So I'm going to use a few different rules here. I'm going to use the distributive property first. So 3 times v is 3v, plus 3 times 2 is 6, and then I still have the plus 7v here. I can combine the 3v and the 7v because they have the same variable. So that's going to be 10v, and I still have this plus 6, so I can't just ignore it. Now, can I combine 10v and 6? No, I can't combine those terms. So I am comparing that now to 16v. Well, if I'm not sure, I can always grab a number and plug it in. Okay, let's grab 2. So if I plug in 2 here, that would be 10 times 2 plus 6. 10 times 2 is 20, plus 6 equals 26. And if I plug in 2 here, that means 16 times 2, which is 32. 32 and 26 are not equal, so these two expressions are, drum roll please, not equivalent. All right, let's go on to the number 6. Okay, again, here I only have 2 terms, so I want to whittle this down to 2 terms. Right now it's 3 terms, so it's all addition, so I can combine these like terms. 14 plus 11 is 25, and the h stays, and then we still have this plus 17. And now look, first term on this expression 25, first term on my new expression after combining this is 25, then plus 17, 17. They're now exactly the same expressions, so no matter what number we plug in, we will always get the same answer for both, so they are equivalent. Alrighty. So here I can use the distributive property, or there's a few ways I could say it. 7 times 4b though. 7 times 4 is 28, and then the b stays. And look, now it is exactly the same as 28b, and I've changed this to 28b, so these two again are equivalent. All right, let's go down to 8. Each case of dog food contains C cans. Each case of cat food contains 12 cans. 4 students wrote the expressions below for the number of cans in 6 cases of dog food and 1 case of cat food. Which of the expressions are correct? So each case of dog food contains C cans, so we don't know how many cans, but they're buying 6 cases, so 6 times however many cans are in each case. And 1 case of cat food, and cat food they told us contains 12. So that's what I want. 6C plus 12, I see that here. Now this is 6C times 12, so that's different. This one, if I do the distributive property, 6 times C is 6C, plus 6 times 2 is 12. So this is also a correct expression. So remember, we talked about earlier in the chapter, there's room for some variability as long as you end up with the same answer, the same value. So these two expressions have the same value. They're equivalent expressions. So both of these students would be correct. Okay, now let's check out this last one. Here we can do the same thing. Really, this is 3. I can change the order. Times 2C plus 4. And again, I can do the distributive property. 3 times 2c, 3 times 2 is 6, and the c stays attached, plus 3 times 4 is 12, and now look, I have another one, 6c plus 12, 6c plus 12. So all 3 of these are equivalent. So all 3 of these would be considered correct answers. Okay. So that, again, that's the story with math. There's always more than one way to do it. And the way to check it is to simplify it. Another way to check it is to actually plug in a number for C. Okay. Now, generally speaking, don't pick 0 or 1 because sometimes some fluke things can happen. And if you want to be really certain, plug in 2 numbers. So try 2, for example, see if those become equivalent. Once you evaluate the expression, if they're equivalent, you want to just double check. Choose another number like 5 that's easy to multiply or add, and check again. If you end up with evaluating the expressions and they all are equivalent again, then you know you have equivalent expressions. All right, thanks for watching. I'll see you on the next one.